I guess I can take the mic. How long is the recording going to go?
Over there.
Is this going to be the release party? Denver. Wow. We should do that. We need to record the release party. So why not I just I haven't talked as much about assets.
Yeah.
See, full room. Nice. Yeah, man. Me.
Okay, let's get started. Welcome everyone. This is the Apache Cassandra track. This is the start of the track. I would like to invite here the Cassandra showman, also known as Patrick McFadden. He will be the MC for today.
Follows on the mailing list. He's like, or he's on Slack. He's like, can you come up here and do this? I'm like, sure, why not? So welcome. Look at this full room. Everyone is in the back. All right, that's good. So before we get started, thanks to the mini Cassandra Summit this is going to be an action-packed couple of days. So I have to ask, how many of you have taken the Apache Cassandra user survey? That's a shockingly low number. Everyone in this room had better get that filled out by the end of the day, and I have the list where I can see who did. So I will stock you, and I'll give you t-shirts. First talk, I'm really excited about this because John keeps like sending me messages. Dude, get out there. He keeps
Check it out, man.
check it out, and he gets like, you won't believe this. He'll get me on a like Google Meet or something, and be like, check this out. It's really cool. But I just love that these two are teaming up because this superhero duo. But John, you and I have been doing Sling and Code for a long time with Cassandra, but I feel like you know the most about failure.
I have failed.
So I'm really looking forward to it, guys. Impressive.
All right. Wow. Love it. Well, after something like that, let me just depress the room a little bit. Let's just calm down, everybody, relax. Let's just start with a little Q&A. Usually you don't get that front, but we're mixing it up. I'm just curious here. How do people in this room test upgrades, config changes? How do you figure out if you're about to break a production cluster? Do you just kind of go for it, or do you have a really good testing system? How can you be confident? Who here's running a cluster that they test somehow? Or how do you test?
We have canary tests, we have monitoring, we have integration tests, unit tests.
Okay.
So before deploying something in production, we have also staging area, a staging cluster where we can run performance tests, something closer to the production workload there.
I love this. Yes, this is great. A lot of teams don't actually have that. A lot of teams will just roll things out and hope for the best. Or they won't do anything because they're completely paralyzed because they don't know how to evaluate whether or not the thing that they're about to do even makes any sense. And that's pretty tricky, and I've definitely seen that in a lot of cases. So let's do a quick intro. So I'm John Haddad. I've been involved with the Cassandra community for, I think it's now about 12 years. There's a few people in this room that I got started with back at this tiny little startup in Santa Monica, and then moved on to DataStax, The Last Pickle, Apple, Netflix, and now I run my own consulting company, helping people with Cassandra and platform engineering. I really tend to kind of focus a lot on observability and performance and doing things confidently. So I'm kind of obsessed with that.
And I'm Jordan. I've been working with Cassandra for, I think it's almost 10 years now. I forget exactly what year I joined Apple and started working on it. I'm currently at Netflix, where we have a pretty large deployment of Cassandra, and then I'm a committer and PMC member. It's weird for me to say, especially now, Netflix wasn't known for hiring younger, early career engineers, and we do now, and so I get to say all the time that I've been working for 2 decades as a professional engineer. That's really weird. About half of that's been on databases. So before I was working with Cassandra, I was working on a database called React, which probably these days very few in this room have heard of anymore, unless you know me personally. I see Doug back there who worked with me on it back in the day.
So we're going to dig into some of the tooling that I started working on 5 years ago back when I was a principal consultant at The Last Pickle. I was kind of the guy in the team that would get thrown the dumpster fires. That was just sort of the thing that I enjoyed for some weird reason. I like figuring things out. I like the challenge. I like the detective aspect. But one of the things that's difficult is if you can't put yourself in somebody else's shoes, if you can't figure out exactly what somebody is doing, it can make it really hard to just sort of move your way logically through a problem and be able to diagnose what's going on, especially in some more obscure situations. And so I started out starting with a load testing tool that at the time was called TLP Stress. It's now called Easy Cast Stress. It's one of the tools that we're talking about. And also another tool called TLP Cluster, which is now called Easy Cast Lab. And basically what I wanted was a way to create environments where I didn't have to spend a lot of time dealing with complex provisioning tools. I didn't want to deal with Ansible and building out Puppet or Chef configs and all the production type things that you really want. It turns out aren't that great for setting up a lab. What I really, really wanted was to be able to get going in 15 minutes with Cluster, any version of Cassandra, any config changes I want, do mixed versions, do all sorts of weird things, break things deliberately. And that's how this tooling was born.
And then for me, usage is a little bit different. So like I said, I'm a developer, working on Cassandra day to day, and I'm also an operator. And so often I want to qualify some new feature I'm working on, maybe a patch or a change, a config change. Maybe a customer says like, hey, we want to change X. I'm like, oh, if we change this tuning, and I want to test that. And the first question might be like, well, you work at one of these big companies, don't you have all this orchestration tooling to do all this? And that's true, but my tooling is set up to run one specific version of Cassandra, maybe 2. If I want to run something new, I've got to do several hours worth of work to get it all put together. And then and then when you get like a custom build, right, we're going to talk a little bit about the patch John and I worked on together and qualified with this tooling. And to get a custom build in like internally is a huge hurdle, and I don't want to jump that hurdle just to get there. So we want to have an easy way to test these changes. And then as an operator, upgrades and configurations. So I have the pleasure of doing both, in Cassandra. And so like a major version upgrade, we might want to test. I might want to test something's configuration specifically against a specific workload. Or I may even want to see like, you get the questions on the mailing list, like does it work to go from 3.0 to 4.1? Or do I have to go through 4.0? And so I want an easy tool that helps me answer all these questions. We have some of that tooling already, besides the internal stuff at the big companies that I've worked at. We have tools in the open source community, right? So we have CCM. We're talking about adopting CCM for the project as a first-class sub-project, which I think is great and we should do. But CCM gives you a local cluster. You got to do these gymnastics with the IPs. It's nice when you're like quickly testing the patch real quick. It also has a way to like point CCM at your local source branch and make things run, although it's a little bit more tedious. But it works. But it's not great for anything that like mimics a real system. So I'm not going to do benchmarks with CCM. I'm not going to do performance tests. Maybe I can do things like make the network fail between a couple of nodes. But past that, I'm not going to do anything that realistically mimics my production environment. And so that's the biggest sort of limitation for me with CCM.
So the next question is, can we use something like Cassandra to do some of our testing? And this is kind of an interesting question because you think the obvious answer was yes, it's so much for you. You've got this operator, it just kind of like, you point it at your cluster and a lot of things just kind of happen. But there are actually a few challenges with this. One, you kind of already need to know a bit about Kubernetes. If you don't know a bit about Kubernetes, then your problem becomes now you're learning Kubernetes, you're not actually figuring out Cassandra. So if this is something that you're not familiar with, that's definitely a challenge. I also have on here fighting the operator, because there are times where you want to get your cluster in a particularly weird situation that Kubernetes might not want you to do. And so if you start using the operator, it's going to start making changes. And what you really, really want is to get your cluster in a completely broken state so that you can figure out exactly how to get out of that problem in kind of a manual way. Where Kubernetes might not be ready for, or the operator may not be ready for the kind of state that you're in, and you need to do a little bit of tinkering, and it's just not a great solution for that. Doing arbitrary builds is a little bit more of a headache. If you want to do that, now you need to start building Docker containers, so you have to have a whole workflow for that. You need to, there's no support for older Cassandra versions, so as a consultant, I will frequently still work with teams that are running Cassandra 2.2. There's literally a question asked yesterday or the day before in Slack if someone's using Cassandra 2.2. And if we can't use that using the operator, then it really doesn't help. And it also doesn't help if now you're using an operator where someone else is actually using like an AMI. And here's the other thing. Running production clusters, the demands are just so much different from running the lab. Labs are literally meant to set up bizarre situations that are meant to be broken. And so I find that Cassandra is really, really not a great fit for this use case. And the last thing here that's kind of important, to use stateful sets with Cassandra, it's actually expecting disaggregated storage. So if you don't, let's say that you want to run with locally attached NVMe drives on instance store in AWS and test the performance of that, can we maximize the throughput? You can't actually run that test using Cassandra. It doesn't want to do that. It wants to use EBS because the volumes can get, the instances can get killed, the pods can get killed at any time, and it wants to reattach them. There's a whole thing there. So for me, to have the most flexibility in testing side of things and understanding how Cassandra works, this really isn't a very good solution. So the ideal testing tool for me is something that works with the fact that I'm an incredibly impatient person. I get annoyed really, really easily. So it has to be something I can set up in just a few lines of bash. I want to run 5 lines, let's say, and have a cluster up and running. Maybe I have to go get a coffee while it spins up some instances, but for the most part, I don't really want to wait on a lot of stuff, and I don't want it to be particularly interactive in this process. I want to easily be able to change configs. Now, this is kind of what I mentioned before with Ansible and Chef. I don't want to have templatized configs where I need to go in and read a bunch of stuff. I actually just want to get my YAML right in the local directory, mess with it, maybe put it on some hosts and not other hosts. But I really, really don't want to do a lot of work to get these lab environments up. And one of the things that's really important for me is to have rock solid observability. For those of you that have heard me talk about observability in the past, I will frequently talk about flamegraphs and eBPF and kernel metrics and what we can get out of the underlying system. And it's really, really important to me to have this stuff built in, out of the box, ready to go, fully integrated into my tooling and easy to use. And so that is how these 2 tools were born. Very, very exciting. So there I was, annoyed that I didn't have the tool, and I hacked together some bash, and then all of a sudden I turned it into like a real set of tools written in Kotlin. A combination of load testing and cluster provisioning allows me to test pretty much anything that you can think of. I've tested some really wild stuff here for clients, for open source patches in Cassandra, working with Jordan. working with Alex in the back, Stefan as well. There's been a whole bunch of patches that we've used this tooling to qualify and to find like some remarkably low-hanging fruit with fairly quick fixes that are going to be delivering massive improvements in performance. So this is the exciting part where we just dip our toes in for a live demo. The Wi-Fi, dicey. Who knows if it's going to work? Let's find out. So what we're going to do here, the first thing that we're going to do is we have our initial directory. So this is our community over code directory, and we're just going to initialize this directory as an EasyCast Lab environment. And you can see here it's pretty straightforward. All you do is you run this init command, C6, that means that this is a 6-node cluster. S1, that means we have 1 node for EasyCast stress, and we give it the name community over code, and we tell it, we're going to bring up these instances automatically. So this is literally just writing out a Terraform configuration file and then applying it against my AWS account. So it's going to go ahead, it's going to launch my instances. There's a lot of different options in here. We're not going to show them to you all right now, but you can do really fun things like configure EBS volumes. You can use any EBS type, you can attach it to the image. It's also going to dump a whole bunch of shell scripts in your local directory. You can edit those. You can do anything that you want. It's really, really meant for someone that wants to tinker. This is not a tool where you're going to sit there and go, oh, wow, like, I don't have to, know anything about the underlying system. This is meant for people who really, really want to get their hands dirty and understand exactly what's happening at the system level. So you can see here, this is just going to take a second. Apparently it has to pull this down, even though I just did that. Super lame. So it went
slow on the conference Wi-Fi.
Yeah, because we're doing this over conference Wi-Fi. Great.
But I think a couple things to add while waiting for it. The idea is to be able to get it up and running without thinking much about this. So there's a step we're not showing here, but basically it would ask you for your AWS credentials. Right now the tool only supports AWS. We can talk about a little bit more in the questions and answers about supporting other backends. But other than that, it sort of self-contains all the dependencies. So everything runs in Docker in the background. So it's using Packer, it's using Terraform, but you don't have to install any of that to set this up. And we'll talk about getting set up a little bit later. But you can see, and that's what it's hanging on right now, is installing the AWS like plugin for Terraform. But once it skips that part, it'll provision the rest.
Yeah, it usually caches this, and it's weird because I just did this 5 minutes ago, and it didn't take that.
That's why live demos are fun.
Yeah, live demos. This is always going to happen. It's guaranteed. We actually have backup slides. We can just punch over those. That's right. Yep. So this is what you would see. It went along the way. So I think that this is where we're stuck right now. So installs, I think this said 5.70. Maybe they published it in the last 3 minutes, which is great timing. But essentially what we have here, like Jordan said, is Terraform is running in the background within the Docker container. What EasyCast Lab does is it actually sits in the middle and does kind of a man-in-the-middle attack between your keyboard and the Docker container. And it's basically reading the standard input and output and proxying everything back and forth. So it feels like everything's running locally, but it's actually running inside of the container. Do we have a thing yet? Did it happen to finish?
No, it's still the same.
Ooh, live demo. So the next thing that we end up doing in this process is we say use and then whatever version you want. The really cool thing about this is that these versions are generated just from a YAML called Cassandra versions. And you put the version that you want in there, you say the Java version that you want it to work with. It's remarkably easy. You can add a new one and then you run the command to build the AMI. What's really cool about this is it doesn't just work with regular releases. You can, I think we might have some slides about this coming up, but you can, this is wildly configurable. You can basically do if you want anything.
Yeah, so one of the ways that I use this is every time Mix starts a vote for a new release, I go grab the link, I put it in Cassandra versions.yaml, rebuild the image, make sure a cluster starts up, can execute a few commands, the vote gets my +1.
And that's about 10 minutes,
Yeah.
like maybe 1 minute to add it to the YAML, 5 to rebuild the image.
I go make a coffee in between.
Yeah,
Because
exactly.
Marshall doesn't like you, so.
Oh, okay. Well, we'll just move on. What do we got next?
This is just showing the use, so you can.
Oh, yeah. Okay. So our use command basically SSHs into each node, and you can see here where it's doing it. This use Cassandra thing. What's really cool about that is, like I said, the Java version is in there. So when you say use Cassandra 5, you can tell it I want to use Cassandra Java 17 or Java 11, whatever it is, and it'll automatically go through and make those updates for you. You can mix and match. You can have one version. You can have one node on one version of Cassandra or Java, a different node on another one, or you could have all the nodes in your cluster use, let's say, 5.0, and then you could have a new node, like you could have one node that's using 5.0 and then the tip of the 5.0 branch. Because we actually build the 5.0 branch and the trunk branch, and we will build the accord branch, and we'll just include that. So you'll be able to just use 5.0 or use trunk or use accord. You can actually get started kicking the tires on this stuff right away. You won't have to do any extra work if you want to test out accord, which I think is pretty awesome.
So let's check in and see.
How we doing? Nope. Maybe we control C it. Maybe it's dead.
The internet, you might need.
Oh, I know why it's not working. Because I killed Doc. I'm an idiot. No, it was you. Yeah, it's me. I'm the problem.
Do you deploy on Fridays too?
Oh yeah, every Friday. Right? Yeah, right before I go to sleep. Friday night, have a couple glasses of scotch, deploy. See you tomorrow. We'll see what happens. All right, look at this. Is it happening? Are we getting it?
No, it'll stay in the same place for
No. You know what? Actually, I think I was wrong. I must have still been running Docker because this wouldn't have come up.
Are we getting a live coding demonstration too?
Dude, I would love to. Yeah. My elite coding skills.
I made him promise me if we did a live demo, we had backup, so at least we're prepared.
Yeah.
We can talk about patch a little bit.
Yeah.
Come back and check.
Yeah. So one of the other things that I mentioned is the ability to make arbitrary changes to the YAML. So we have this YAML patching system. Instead of downloading a 1,500 line YAML, whatever ridiculous thing that we're up to now. Oh yeah, it's something like, it's over 1,000 lines, I think. What we do here is we have a patch. And so the patch file is basically applied on top of whatever's sitting there in your base directory. So you can make arbitrary changes, but you don't need to look through everything because that seems like a lot of work to me. So what will happen here is it'll write out some basic stuff, like it'll put out seeds for you. So after you do the up command, writes this file out, you can go ahead and make changes to it. Like let's suppose we wanted to increase the number of concurrent writes because 64 is not that many. We can do plenty more than that. So if you wanted to go ahead and turn that, make changes to that, we then have a nice command called update config that will go ahead and just apply that configuration to the entire cluster. And of course, we also have commands to do rolling restarts, or you can restart individual nodes. You can also apply these changes to specific nodes. So there's a hosts parameter. So if you want to say, hey, let's just see what happens when we put one node at 2 concurrent writes. Let's see what happens. You'll find that it backs up fairly quickly. But the other nodes do just great in comparison.
Yeah, so one way I just used this weekend is, how many people know that you can actually specify initial token with all of your vnode tokens? Like it's plural. Few of us. So I didn't know that existed. Like I run with initial token because I'm one of those crazy people that runs with no vnodes and one token. But I had to help someone who used vnodes, and I wanted the vnodes of one cluster to match the other. And so I looked at the docs and I was like, oh, initial token takes a list. I have no idea if that works. I could go read the code. Instead, I just used this. So I made 3 patches, one for each node. And then like John said, you can have these apply on a per node basis. No, it's still sitting there. So since we were just, since I wanted to test all of those on a per node basis, I just sat there and uploaded the config of the initial tokens to each one. And so it's really useful to be able to do that really quick. I think you just got to finish.
You might need to reconnect the internet.
Want to come back tomorrow?
Yeah. Oh, this is why we had slides.
Yeah. I will come back tomorrow. Let's just keep on this. All right, we continue. We march on. Okay. Boo. Okay. And then, so now that we've gone ahead and initialized the directory, we've called up, in theory, it would start the instances. You can, after you've gone ahead and made any configuration changes and you pick the version that you want, you just call start. And this will literally just go through one by one and start the nodes. It does it in the safe manner. It actually waits for the node to come up. It makes sure that JMX is online, CQLSH is online, and the node has been bootstrapped in, and then it will move on to the next node. So it's a safe process that we can actually get very easily get our cluster up. So at this point now, we would actually have a cluster up and running. So you can see here, I started a node, a cluster with 6 nodes. 6 nodes are up and running. And then it drops a file called env.sh. So when you source that file, you get a whole bunch of really, really useful aliases that show up. The ones that you probably use the most would be C0 through C whatever. Go to the end, go to the last number that you have. So you can do C0 will SSH into the first node. There's aliases for SSHing. It handles the SSH config, so you don't have to deal with any of the key management. Like it handles all that stuff for you out of the box. Oh, okay. Let's bring up the cluster. Let's just bring up Jordan's cluster. That's the backup. Okay.
These parts.
Can you make the screen a little? It's a little bigger.
Screen.
Yeah. Okay. So Jordan's already created this cluster. Luckily, he has power and foresight, and was much less confident in our ability to have bring up a Cassandra cluster from a conference. Come on. Yep. So that's the exact thing that I just mentioned. Source the environment.sh. Now, one of the things that we have here that Jordan has on a screen here that's really, really useful. You've probably, if you've heard me talk at all over the last few years, I talk about flamegraphs a lot, and like I don't ever stop talking about them. And as soon as everyone starts using them all the time, then I can stop talking about them. But until then, I will not stop. So there's a really nice alias on here called cflame. Cflame, you just pass the host Cassandra 0, and it will connect to the host. It will automatically start collecting a flame graph, and then when it's done, it will download it to your local machine. So when it's done, you just open that up, and you actually have a nice little performance profile, and you can figure out what has been happening on the machine.
See what
Yeah, let's take a look. What's it look like?
empty Cassandra node if I could use my mouse. I don't
boy.
use the trackpad anymore.
Oh no. No, that's not gonna work. We gotta get rid of the mouse.
It's gonna be artifacts, right?
Yeah, artifacts. Artifacts Cassandra 0. So all the artifacts, so you can use, there's an artifacts directory that's on each machine. You can essentially use it as kind of a dumping ground for anything that you want to save. There's another command on here called CDL, Cassandra download, and it connects to all the machines and rsyncs everything that's in the artifacts directories and pulls them down. So if you're working with multiple people, like we worked together on a few issues in the past, it's nice because I can just like run the results of a command and I tee it to a location in mount artifacts or mount Cassandra artifacts, and then he's able to download it when I'm done. We can do our analysis on the same data sets, which is pretty helpful. So this is just all the aliases that get set up over here, which is pretty
Plus a
helpful.
couple of mine,
Oh, nice.
but
So are we?
all these get added. So should we kick off on a stress run?
Yeah, let's do it.
So this right here is an example of one of those conveniences. So you just want to get on the stress box. It makes all the Cassandra boxes C0 through Cn-1, and then same with stress. So you just type S0 and your SSH in the machine. So to a point John made earlier, right? Like once you have an instance, you don't need any other tooling. If you know SSH and you know Cassandra, you can use this tool. There's nothing else to use. You don't need the Kubernetes knowledge, etc. And so John's getting ready to run down here an easy cache stress workload. So again, part of this is to run load tests. So we didn't just provision 6 Cassandra instances. We also provisioned 1 stress box. You could provision 10 stress boxes if you'd like. You want to kick it off?
Yeah.
See how good John's knowledge of his own arguments are.
I forget all the time. I never get it
And
right.
if the internet, yeah.
Nailed it.
So if you haven't seen Easy Cache Stress, it's really awesome. It's a great benchmarking tool for Cassandra. John has it doing a pre-populate phase right now, so you can have it like write a bunch of data before you do a workload. We actually talked about building a feature for this talk where you could like pre-populate like EBS volumes and then load them. We didn't get to that in time, but you might see that feature coming down the pipe. Especially because we tend to like to test things with like a real data set, not one that just fits into your page cache on a machine. But so this will do some pre-writing. You can sort of see here, he's configured it to write 1 million keys, and then afterwards it'll do about 20,000 RPS. It'll run for an hour, and then it'll run over those total of 1 million keys. Easy Cache Stress comes with these built-in shapes of workload. This one's called key value. You can write your own. They're just little Kotlin interfaces that you implement. But this one looks like a simple key value endpoint, and you can see the structure right here. You can also change things like compaction on the table and things like that. So if you want to test different configurations, basically any of this stuff can get configured. You can also test different consistency levels. We're using local 1 here, that's the default. And then if you are a Prometheus user, you can actually have Easy Cache Stress talk directly to Prom, which is pretty cool. Like John said, the goal of all of these tools are metrics out of the box. We're going to be talking about a different tooling called AxonOps, which is what we tend to use for quick stuff. You can get a free 6-node cluster to monitor from them and use the tooling with. And then also Easy Cache Stress dumps a bunch of like metrics to the terminal here. So they're a little bit on the zoomed in screen, kind of not formatted well, but if you were on a normal terminal window, there'd be 1 table here. But you get basically reads, writes, deletes, and in each one you get a count of how many it's done, P99 latency, because that's the only latency worth looking at, and your RPS over the last minute.
Yeah, and there's a whole bunch that we can go into here. I mean, I don't think we're gonna have enough time to do all the stuff that we'd love to take a look at. But as Jordan mentioned, you can reconfigure compaction, compression, pretty much any table parameter. You can pass additional CQL. So if you wanted to create an additional secondary index on top of an existing thing, you can do that. Are we going to Axon? Yeah. All right. So we have here, one of the things that's really cool, AxonOps allows you, as Jordan said, to run metrics for free. So every cluster that you provision, if you put in your key for AxonOps, you will automatically get these very high resolution metrics. They actually do 5-second metrics collection, which is better than anything else I've seen. If you try to do that with JMX Exporter, you're basically going to spend 50% of your CPU time collecting metrics with a large cluster. It's just not great. This is the only metric solution that I've actually seen that doesn't have massive performance overhead. So I really, really like this for doing tests. It's also really nice from the standpoint of if we're trying to get something committed into the project, we don't need to set up a totally new thing. Like we can all just use this free tooling. So to me, it's very cool that they've made this available to us for free.
Unfortunately, the conference Wi-Fi doesn't like loading all their metrics.
Conference Wi-Fi does not like loading their metrics, is what I've discovered.
But we have a bunch of screenshots from the testing that we've done with this that will show those dashboards. But yeah, do you want to? We did see Flame. Do you want to do bio latency?
Yes.
I'll do it on this one real quick.
So I mentioned Linux performance tools, BCC tools, eBPF, tapping into kind of the power of what's available in the Linux kernel. I really, really like this package called BCC tools. It gives us deep insight as to what's happening at every single level of your hardware. You can find out latency statistics coming off of all of your block devices. You can learn about what's happening.
It's going to want to do that download BCC tools thing the first time you run bio latency. Oh no, that should be Amazon.
No, this should work.
Yeah.
As long as you're Prove what you want, great. So bio latency is really cool because you'll get a latency distribution on your everything that's been submitted to your block device. I actually used this multiple times back at Netflix to solve some really bizarro performance problems. But Jordan and I also use this tooling to evaluate the patch that he just wrote, which gave absolutely phenomenal results, and hopefully we can get it merged in soon. That improves the overall performance of the patch. So you can see here we have our latency distribution, coming across 10 times once a second. So this is really powerful. You can do the same thing at the file system level. You can get access to a lot of useful metrics at the network level. There's a ton here. You can find out all the syscalls, distribution of syscalls. It's actually how I found out that we do way more syscalls than we should be. We can get a lot more efficient if we just do a little bit of optimization around that. I think we only have 10 minutes left, so we have to switch. But I'm just going to say access. All right.
See, we made the live demo work. You used to have a box in code, she would say prior planning prevents piss poor performance. It sort of feels like that's relevant here.
We haven't mentioned this. I'll just move on.
Yeah. All right. You want to talk about this?
Oh yeah. So there's a few examples of some things that we recently worked on. So Cassandra, what is this? 19477. Do not go to disks. It turns out that we had a situation where every time that you went to write a hint to a file, it would check the size of the file to see if it was too big, and it would create the name dynamically. When doing that, we discovered that using the flamegraphs, we're actually spending 6% of our CPU time just in evaluating whether or not the file was too big and what the name of the file was, which is a ludicrous amount of CPU time for like hints, because the more nodes that go down in a cluster, the more hints you're going to be storing. And if you ever had a multi-DC situation where your connectivity between them was severed, you would end up in a situation where both DCs would now have significantly increased CPU load. And it wasn't trivial. So when we actually looked at the overall load on the system, this is the patched version. So I worked on this patch with Stefan. And so our patch version was sitting at 50% CPU utilization. And the release that we had shipped with this bug was in the between 80 and 100% CPU utilization. So this is a massive amount of savings just from doing a really, really tiny fix. And the only reason why it was obvious is the profiling tools that I used to find this. There's also some work here that Alex Petrov is going to be talking about later today. This has long since bothered me that we allow essentially like an infinite amount of things into a queue that we won't be able to service, and we just create to a ton of allocations, and then the request goes ahead and fails, and the client has long since stopped listening for a result. So Alex did this patch. I had filed this, and Alex came along with a patch like 2 days later. Magician. And I did the evaluation of this patch and found that the performance impact, the improvement to availability was absolutely mind-blowing. Like a cluster can recover like minutes faster than it would before if you ever kind of tried to tip it over by utilizing this patch. This went into 4.1.6. The improvement is amazing, and so it was really, really cool to kind of find this, figure out what should be done, collaborate with him, and be able to evaluate the effectiveness just based on the tooling out of the box.
Yeah, and as someone who's getting ready to deploy this patch, we just deployed 4.1.6 internally. It's really nice to look at a feature and be like, oh, it does the thing, like, not the engineer, like, has determined through, like, logical thinking that it does the thing, but, like, it has been demonstrated that it does the thing. Before this, when you hit the queues getting really long, you're just rolling restarting all the time. We actually have auto remediation that just kicks off a rolling restart when the queues get too big. So really, really excited for this patch. And again, it's really awesome that it comes with proof that it works. Another patch, and I'll be talking about this in detail in terms of implementation tomorrow in the Birds of a Feather afternoon session in this room, is around improving disk access patterns during compaction. So when you have compressed data in Cassandra, and most of us do, we read each compressed chunk in its own file system call. And that can be really, really, really bad for performance, for compaction, especially when you have disaggregated storage like EBS. It can make your EBS throughput terrible, and you can run out of IOPS really easy. Anyone here run EBS in the room? Just a quick show of hands. How many of you have had it just fall over when you hit the IOPS limit? You hit your IOPS limit before? Yeah, okay. And so we were hitting this all the time at around the same time that we were hitting it, and especially at GP3, where you can control these IOPS, what we tested here. John showed me this. He had some hard time getting traction that like fixing it would be beneficial. And I was like, well, you have the tooling, you have this, like, let's try. The biggest read here you can see is 16K. We're doing reads as small as 512 bytes, and a lot of them. So again, how the patch works, we'll talk about tomorrow afternoon. I think it's at 4:55 in this room. But John and I did a live stream together where we tested this using EasyCastLab. You can actually watch us using the tool live, playing with the nodes, all that stuff. These are axon up graphs. But this green line is bytes read per second off of a machine that has the patch with the EBS disk, GP3, versus the machines that don't. Often I'll have coworkers who are like, hey, can we, bump the compaction throughput on this cluster? There's a lot of CPU room. And then I'll look and I'll be like, it's EBS, and I'm like, you can. It won't do anything, but you can. Throughput was unlimited from the Cassandra perspective in these cases. And you can see, I think we don't have the axis here, but this is just a little bit above 100, and this is down at like 25.
I think it was 12.
Yeah. So really, really poor performance. And then the other problem is that if you start to hit your IOPS limit, each of these are starting to eat away at your IOPS. So this is throughput, but the graph sort of inverts for the number of IOPS used with the patch. And so again, we were able to test that and show it and demonstrate it. And that makes bringing a patch that touches the internals of the read-write system in the database much easier to, make a case for internally.
So obviously, we've shown you a wonderful demo, and you're thinking, oh my God, it went so flawlessly. How do I get this? How do I use it? I'm so convinced. Well, it's just available here on GitHub. We have a really nice QR code here if you want to just take a shot right there. You'll be able to do it, or you just go to type in EasyCastLab, you'll find it. It's also available in Homebrew. Jordan took care of this, so now it's really, really easy. You just install EasyCastLab. I do frequent releases. The release comes with an AMI that's already built, so you don't even have to build the AMI. You just install EasyCastLab. As long as you're using US West 2, it'll just work for you automatically. So it's pretty convenient.
Should add. We'll be doing this for EasyCache Stress as well. I'll be hanging out this week doing that, and then you'll be able to install EasyCache Stress the same way. If you're if you are using CCM and you still want to generate a workload or something like that on your Mac.
And the last thing that we're going to talk about before we shut this down, we also have a training program where we use all these tools. So I talked about how we use them as consultants and committers, but we also use this for training. So Jordan and I built a training program where we've had students come in, we teach them how to figure out what's going on inside Cassandra. We teach them these tools. We empower them to be better. And we actually have had Cassandra consultants come through this program, which honestly at the time I was like, oh my God, these people are my competition. Like, do I even want to allow this? But the world is better off if we spread knowledge. So one of the consultants that took the training program said, I like to look at the ROI of things I put my money into, and in this case, it's just too high to calculate. Using these tools has helped him solve major problems of the customers that he's worked with, and he was willing to say this for us, which is pretty remarkable. I actually cried a little bit when I read it the first time because it was so good. So yeah, I think that's it for me.
Yeah, just to add to that, I think one of the reasons the training is effective is because we use the tooling and it's hands-on. So it's not just John and I lecturing at the people, but we actually use the tools to break clusters and then have the people fix them. So another way that we've used EasyCastLab hands-on to actually get real Cassandra experience. Yeah. With that, thank you all for bearing with our live amazing demo. And any thoughts, questions, we'd be happy to take them. I think we have 3 minutes left. Alex in the back.
So if somebody started clapping, so probably we should.
Because you're gonna put it back.
Yeah.
Yeah, I did have, didn't just. So you mentioned the hints, and did you test this before 195.3.4 or after? Because like there was a massive problem of hints build up that was caused by and was sort of like contributing to the rest of the problem. So I'm just curious whether, when you tested it.
Yeah, so real quick, Alex's question was, we talked about two patches, 19534, which fixed the queuing, and the previous one, I don't remember the number, but that dealt with the hints. And Alex asked if if John had tested that before 19534 or after.
Yeah, the hint patch went in maybe 3 months ago. So it was before your patch was out. So I didn't do anything else with it.
All right, thank you.
Yep.
Any other questions? So I'll answer one question we got earlier today, which is, will it work for anything besides AWS? And the answer is it can. It uses Terraform right now. Anything else we use, you just need to be able to build an image on the other provider, and then you need to provision instances, and then the rest is all the flame graph, everything else will just work. John and I tend to be very need-driven development is the nicest way I can say it. Right now, we don't have a need to run it on anything besides AWS, but if you do, I'd be happy to walk you through where you'd make those changes, because we'd love for it to support other cloud providers or like Docker and Kubernetes or something. Kubernetes might not make the most sense. We're still debating that, but at least Docker as a packaging instead of like an AMI.
Cool. All right, I think we're out of time.
All right, thank you all.
Thanks, everyone.
Software.
Technology.